Welcome to section 9.8, Pythagorean Theorem and Space Figures. Today we're looking at how do we apply the Pythagorean Theorem to 3D shapes. So we're not inside a plane anymore, now we're looking at 3D. So we have two 3D shapes that we're going to really focus on today. One is the rectangular solid. And as the name implies, it is a 3D shape that is made of rectangles. So in a rectangular solid, each face is a rectangle. So we've got a face here which is AEFB. There's one of our rectangles. We've got another face over here, BFGC. We have another one at HGCD. In total, we're going to have 6 rectangular faces. 2 in the front and back, 1 at the top and the bottom, and then, 1 in the front, 1 in the back, 1 in the top, 1 on the bottom, 1 on the left, and 1 on the right. Each segment that's not inside the rectangular solid is called an edge. EF, FG, BC, and so on. Those are all edges of the rectangular solid. So we have 4 of them contributing over here, another 4 over here, and then an additional 1, 2, 3, 4 connecting those side rectangles. So in total we're looking at 12 edges. And then the last thing we're looking at with the rectangular solid, and this is really what you're going to be asked to do on an assessment, is to find the diagonal of the solid. And the diagonal of the solid is completely inside, and it goes from opposite corners. So it goes from one corner all the way across. So we have one here at HB. We also have another one here from G to A. We have one from D to F, and we have one from C to E. So it turns out that we have 4 diagonals within this rectangular solid, and they're all the same. The other shape we're going to look at is the regular square pyramid. Now, the name implies that it is a regular square, which means that the base is a square. Regular meaning that all of the faces are going to have the same basic properties. So they're all going to be triangles. And the pyramid just means that we have one base and then 4 triangular faces. So JKMO is the base. It's a square, JKMO. All the sides, JO, OM, MK, JK, they're all the same. It's a square. P is the vertex, and that's the place where all the triangular faces meet at the one point. It's the tip of the pyramid. So think about the pyramids in Egypt. If you were to climb to the top, you'd be at the vertex. PR is the altitude, which is perpendicular to the base, and it intersects in the middle of the base. So it goes from the vertex right down to the middle of the base. And it's also going to be perpendicular to any segment that you draw in here. And most of the time, RS is the one that we're really concerned with. And PS is something called the slant height. And the slant height is if we go from the vertex down to the middle of the side. It's the perpendicular bisector of any side. And the slant height is just a matter of, if we were to walk up the face of the pyramid, that would be the height that we were actually going to use. If we wanted to describe the height of the pyramid, then altitude would be the better measure. So example 1, we are given that XO is 6, we know that XE is 8, and we know that OH is 24. We want to find 2 things. We want to find OE, and we want to find HE. So first things first, I'm going to write my measurements in. I know that XO is 6, so there we go. Mark it off. XE is 8, so I'm going to mark that one off as well. And then OH is 24. To find OE, I'm going to set up a triangle, and I'm going to highlight this for you in green. And because this is a rectangular solid, we know that all of the bases have rectangles, so we know we have a right angle here. So looking at solving the green triangle, I have 2 sides of the right triangle. I have the 2 legs. I want the hypotenuse. So 6 and 8, that's a triple. And if you're not sure of that, you can always use Pythagorean Theorem. But 6, 8, and 10 would complete the triple. So that means that OE is going to measure 10. I can do the same thing, same basic idea to find HE. But I'm going to use a different triangle, so I'm going to use a different color. And if I highlight this out, we've got our purple triangle there. Now our purple triangle is still a right triangle. When these faces meet, they're going to form right angles, any part of the face. So I've got a triple here, 10, 24, and my diagonal would be 26. So HE is 26. So the math behind it's not that challenging if you know how to use Pythagorean theorem. It's just a matter of seeing where the triangles are at. Triples come into play again. In example 2, we're going to look at a regular square pyramid. They're telling us here that BCDE is a square. We know that BE is going to measure 10. Mark it off. 10 right there. I know that AF is 12. And I want to find all of these pieces. So first things first, I want to find out the measurement of FG. That's the first thing I'm looking for. Now we said that AF, because it goes from the vertex, it's going to be perpendicular to this base. That's our altitude. So our altitude is going to be perpendicular to the middle of the base, and it's also going to go halfway into the base. So if the entire side here is 10, we know that because it's a square pyramid, halfway there is 5. So we know based on the fact that half of 10 is 5 that FG is 5. From there, I'm looking to find the measurement of AG. I'm going to use the fact that there's a right triangle here. I'll highlight this one so you can see where it is. And we said that the altitude was perpendicular to the base, so there's my right angle. 5, 12, AG is 13. From there, I want to be able to find the measurement of AD. And AD is the same all the way around. You're basically looking for the side of an isosceles triangle. So all these edges are going to be the same. So from here, what we're looking to do is actually figure out what is the measurement of this side based on knowing that this is 13 right here and this is 10 all the way across. So what I have to do to find AD is I have to set up another triangle. Let's do this one in green. This measurement AG represents the slant height. The slant height is perpendicular to the base, and it also bisects the base. So if this entire thing is 10, I'm concerned about the 5, because I want to find out the hypotenuse of this green triangle here. And if I can find it here, then it's the same all the way around. So this is not a triple. 5 and 13, without 13 being the hypotenuse, is not going to be a triple. We have to use Pythagorean theorem. So I do 5 squared plus 13 squared, which is going to give me AD squared. So 25 plus 169 equals AD squared. So 169 and 25, that's going to give me 194. And then from there, I'm looking to simplify my radical as far as I can go. So if I take 97 and I divide it by 2, that's going to give me, or sorry, 194 and divided by 2, that's going to give me 97. And that's about as far as I can go. And there's nothing that is divisible by 97. So we are going to call that the final answer. Actually, this won't simplify at all. AD is going to be the square root of 194. From there, I'm looking to find the measurement of CE, which is the diagonal of the entire base. So I need to draw that in first. So let me draw that in. Let's do a red line. Let's do a yellow line. Make this dashed. All right. So CE is going to be this segment right in here that we're drawing. So this segment goes from this corner all the way across. Now remember, this is a square we're looking at. So realistically, what I'm looking at right here for my base is I'm looking for the diagonal of a square with side 10. Now you might know this best if you do the Pythagorean theorem, that's fine. If you know that's a 45, 45, 90 triangle, that's also helpful as well, because these are sides of your x, and then your diagonal is going to be your x root 2. So if the sides of the right triangle are 10 and 10, the hypotenuse would be 10 squared root of 2. And then the last part, we want to find the perimeter of the base. We already know it's a square. We already know the sides are 10. The perimeter is going to be 4 times 10, which will give me 40. So again, nothing extremely new here. It's just a matter of picking out your right triangles where they are and using Pythagorean theorem to solve them. Once you got that down pat, it's a pretty